so far. Yeah, not too bad.
Excuse me.
Yeah.
Why it is necessary to have a ground run if we take the oil level after a few hours?
Why do you need a what? Sorry.
Why it is necessary to have to do a ground run?
Yeah.
If it is very late for the for checking the engine oil level.
To do with the fire extinguishing.
No, engine oil level.
Engine oil level. Yeah. Okay.
It's necessary to have a ground run if there is 2-3 hours. Yeah.
Which part are you on about there? You would do if you want to check the oil level. Yeah. When an aircraft lands, you need to check the oil level.
Yeah.
You don't check it when it's cold. You have a look at it when it's cold, but you don't fill it up when it's cold. You always fill it up when it's warm. Because if you fill it up when it's cold, there's a chance you can overfill it because it's going to heat up, and then it can overfill because the volume and maybe siphon itself off. So most aircraft, you only top the oil up once it's usually within the first 5 minutes or so. But it depends on the aircraft. It could be 5 minutes, 10 minutes, or thereabouts. But you never usually top the oil up when it's cold. Is that what you're sort of meaning there? Does that help a little bit, Whisper?
Repeat it again. It's not so clear in my phone.
Oh, right, okay. Yeah, I mean, with the oil levels, you check oil levels when the engine's warm. You'll look at it when it's cold, but you never tend to fill it up when it's cold. Some engines will let you do that, or aircraft will let you do that, but it has to be only a certain amount. If you fill your engine up when it's cold, there's a chance when it gets hot, it's going to expand and potentially the volume will be too much and it will maybe come out the actual tank or siphon off. So you can look at the oil level when it's cold. You always check it when the aircraft's landed. You'll check it within a certain amount of time. Some aircraft don't. They can fly for long times without checking it. But then usually when you're servicing an aircraft, the last time you'll check it, engines will be shut down. And within a few minutes or so, you go and check the oil levels and make sure they're okay. And you top up as required. Okay.
Okay.
Anything else? Oh, excuse me. Have you got any other questions on book 2 before we go back on revision for book 1? Because there was one thing I was going to do. Just double check myself. I covered that one. Oh, that's what I was going to do if I just remember right. A little bit of fun for you guys. It'll be fun watching me doing it. But I'll get you guys to tell me. Right, let's get this wired up. Bear with me 2 minutes. And that's on there. I'm just going to move this one over. Let's find out where it is. That one. Okay. Right. What I want you to do, I'll go around what I can see at the moment. We've got 9 people there on the screen. We're going to a bit of fun. I shall try my best to draw. I'm not the best drawer, especially on the graphics. Right, let's move that right out the way. Right, what I want you to do, in book 2, we're going to draw the pressure relief oil system. Now I want you to close your books. Okay, even your old books. Don't look at the books. I'll go around you one at a time, but I want you to tell me what to draw. We're going to draw the components first. I will draw the components in black. I'll just make sure this thing's working. see, right, black. Okay, so what I'm going to do is we'll draw the components first. You'll tell me what to draw, and then we'll check the diagram once it's finished. Okay. Once you've drawn the components, we'll then put on the high pressure line, then we'll put on the low pressure or the scavenge line, and then we'll put on the vent line. Okay. So go around one of you at a time. I'll start on the top screen here. I'll start with Pravin. You can hear me? Pravin, you there?
Yeah.
Okay. Tell me, in our oil system, what would be the first component we would put in first? I'll try and draw it. So you guys are going to build up the system. I'm just going to draw what you tell me to draw. So one component each. So Pravin, you tell me the first component. What am I going to draw first in an oil system? What do we need first in an oil system?
Tank.
Yeah, I need a tank. Okay, so I'll try and draw. Oh, no, not going to work very well. Hold on. Try again. There's a tank. I'll just put T for tank, okay? Okay, Sandeep, what are we going to draw next? I'll just draw the components in black. So what's going to come after the tank?
LP low pump.
Pressure pump, yeah, good, thank you. So I'll try and draw it as best I can. So pressure pump, good. Kajendra, what's next?
Fuel cooler, FCOC.
Yeah, FCOC, okay, FCOC. Apologies for my drawing, it's not brilliant on this thing. Okay, good. Who's next? Jimas?
TMB.
TMV, yeah. So we'll put that down right here. TMV. Okay, and Puspa, what's next?
Pressure filter.
Pressure filter, yeah. I'll put PF for that one. And Hamswar, what's next?
Bearing.
Yeah, bearings, yeah. Okay, I'll just draw an equal sign there, that'll do there. Okay, now going back to those components, what else might we have to draw on those components?
Line inlet from tank to
Bias valve.
Yeah, I'll draw a pressure line. Give me a change of color. Let's go for
Bypass
red.
valve.
Pressure line. So we'll draw a line for there, a line to there, a line to there. Nice and easy. High pressure line and a pressure line. Okay. Now what else are we going to have on the pressure line?
Bypass valve.
Bypass valve. Good. So I'll go back to my black there. So it's quite bizarre trying to draw this on a graphics tablet. Okay, little valve there. I'll change the line. What about the FCOC? Will that have anything? Will that have a
Relief valve.
Yeah, well, not really.
bypass.
Yeah. And what about down here, beside the pressure filter? Will that have anything?
Again, we'll have bypass in the pressure filter.
Yeah, bypass. And then what about the whole system? What does the pressure relief valve system have?
The return line to the tank.
Yeah, so I'll have a relief valve, yeah? Relief valve. So, okay, I'll go and join that up now, best I can. So, let's do the pump first. We've got relief. Oh, we're off. Very sensitive. So, that will be the relief valve there. FCOC will be the bypass. Okay. And then we'll have the pressure filter again. Bypass. Oh, too sensitive. Pressure valve there. And then the relief valve, yeah, I'll do a dashed one for that. That's the real watching there. Okay, good. So that's the high pressure side done. What other components have we got?
Scavenger pump.
Scavenge pump. Yeah, I'll put that over here somewhere. Scavenge pump. What else?
And then in again filter. Also a
Yeah.
big filter. Yeah, scavenger.
Scavenge filter. Make it a bit bigger. Yeah. I'll do yes.
And then
Chip detector.
chip detector, magnetic chip detector on the top. Yeah.
Yeah. Let's do that. That should be an M. Okay, so once that side, what about over this side? Microwave, somebody's microphone. If I change that colour to blue, what other component have we got across here?
Breathing.
Centrifugal breathing.
Yeah, centrifugal breather. So centrifugal breather. Okay, so now we can sort that out. Plain atmosphere. And then you can go up back to tank. That's about right there. And obviously this will be attached to the bearing as well. I'll change the colour to green. So there. Then we come up to the filter. Then we come up to the pump. Then we come up to the magnetic chip detector. And then all the way back to tank. Yeah. Anything missing there? Is there anything missing there at all? Apart from a very good drawing. So we've got the tank, we've got the pump, we've got the bypass or relief valve for the pump, we've got FCOC, we've got the bypass for FCOC, we've got the PMV, pressure maintaining valve, we've got the high pressure filter, and we've got the bypass for the pressure filter, and then we've got the system relief valve going back to tank. Yeah. On the return line, let's have a look. Yeah, we've got the scavenge filter, we've got the scavenge pump, which is bigger than the pressure pump. Then we've got the magnetic chip detector, and then back to the tank again. And on this side, we've got the centrifugal breather, which vents to atmosphere, and also a return line back to tank. Yeah, good, good, good. All happy with that one. So with that in mind, what's different? That's a pressure relief valve system. If I take away some stuff now or add stuff, you tell me what to change, and we'll draw in a full flow system now. So what's the full flow system going to have now instead of a pressure relief valve?
Pressure differential switch.
Yeah, okay, so we can get rid of relief valve. It means there's no... There we go. There we go. Get rid of all that stuff because we don't have a pressure relief valve system. Make your own music up as I go along. Okay, so yeah, we're going to have a pressure differential switch instead of the bypass, so we can take a tapping off of there. Well, so it's slightly different. So yeah, tapping off of there. Oops. Get back. Computers are fun. Let's try it again. Where did that go? Where did that go? Where did that go? There's somewhere. Oh, where's that gone? I've just lost it. Oh, there we go. Back again. Come on. There we go. Right, let's try again. Yeah, so we've got. There we go. Right, try again. Where was it? There. Right. So I might actually try with the mouse, might be easier. Okay, so yeah, we'll have a line coming out there. Change that again, colour. And then we'll have our light. There's that gone. See it now, it's too light. There we go. So we'll have our indicator light. Very big light in this case. Okay, so that's the differential one. That'll give a one in the cockpit. And then we have, what else do we have? So we don't have a pressure relief valve anymore, but we do have something else that goes back to tank. So what do we have there?
Differential switch.
Yeah, we've got that one. That'll be the differential pressure switch here instead of the relief valve. So we differential pressure switch. But what about this side?
Spill. Meter is spill.
Meter is
Yeah. Okay, very crude drawing. I do apologise. There we go. So a meter spill back to tank. So it's calibrated to work differently from the pressure filter one or the pressure relief valve system, but there's not much difference. Yeah, we've got meter spill back, we've got cockpit warning light, and that's pretty much the main difference. Everything else is still there. The centrifugal breather, the pump, FCOC, the PMV, the pressure filter, the scavenge pumps, and the magnetic chips are all there as well. Okay, so there's not much of difference between the two, so it hopefully makes it a bit easier. So a bit of fun there. I'm watching how bad I can draw on a graphics tablet. Okay, let's go back to the book. I'll just put these back in again. Switcher 5. That's okay there. And we'll finish that bit there. Okay, doke. Right, let's get on with the next bit. Let's see if we can get this working. Working out. Come on. Wait, might work now. Right. Okay. Right. If you know any more questions on book 2?
No.
Okay, have to do a bit of recap on book 1. Yeah, we'll go through book 2 again. Just to recap what we did start of the week, and we'll see how we get on, and then we'll take it from there, and we'll see how we get on for the next part. So let's go back to there. There's a pointer. Okay. Right, so the question we had the other day, again, just a bit of recap, so we'll go through them again, make sure you're happy with them. So question 1, what are the 3 stages of the pressure volume cycle?
Compress, combustion, and
expansion.
Yeah. Inlet compression is 1, combustion is 2nd, and then turbine stroke exhaust for the 3rd. But pretty much similar as a 4-stroke cycle: induction, compression, power, and exhaust. Pressure volume cycle measures which properties of gas flow?
These properties.
The clues in the question.
pressure,
Yeah. And
Pressure volume cycle.
yeah, that's it.
Pressure against volume.
Yeah, pressure against volume. Just straightforward as that. Definition of an adiabatic process is?
No heat loss.
No, it lost
Yeah.
during
Expansion.
expansion.
Theoretical. Yeah. Net thrust can be defined as?
gross thrust minus momentum drag.
Yeah, gross thrust minus momentum drag. Good. Gas turbine engine thrust is felt where?
All rotating parts.
And
Yeah.
static component.
And static ones as well, yeah. All rotating and static components. When gas flows through a conversion duct, what happens to velocity, pressure, and temperature?
Pressure and temperature drop.
Pressure
Yeah,
and
Pressure decreases.
velocity increases, yeah. Momentum thrust in a gas turbine engine can be considered to be a measure
Outlet gas velocity.
Against inlet gas velocity.
yeah,
Outlet gas.
outlet gas velocity against inlet gas. Momentum of the gas, the mass of gas flowing through the engine is a measurement of the gas going out to the gas going in. In a twin spool axial flow engine, P2 would be where? A twin spool.
LP compressor outlet.
Yeah, compressor outlet.
LP compressor, good.
Mhm.
In a twin spool axial flow engine, T4 would be where?
Lower turbine.
Combustion chamber. Temperature outlet.
Combustion chamber outlet.
Yeah, combustion chamber outlet, yeah. Combustion chamber outlet just before it goes to the NGVs on a twin spool. A triple spool turbofan engine, the rearmost rotating component is and always will be
Lower turbine.
LP turbine, always LP turbine. The nozzle is said to be choked when the exhaust gas velocity becomes
Sonic.
sonic, yeah.
Yeah.
Speed of sound, yeah. Sonic in relation to exhaust gas temperature, and that's where it's important. The exhaust gas nozzle must be designed to produce the right amount of back pressure into the engine, not too much, not too less, okay, to ensure it becomes in that the sonic position. In a variable geometry intake, the dump valve opens when? Or at what speeds?
High supersonic.
Yeah, fast. High supersonic speeds to dump excess mass of air. Okay, good. And likewise, if the aircraft is going supersonic, what position would the wedges be in? Would the wedge be down or the wedge be up in the supersonic intake? Just for next to point.
6.
So the wedge that's in the roof, it moves up and down. Well, if it's supersonic, will the wedge be down or would the wedge be up?
Down.
High speeds. Yeah, it's going to be down. It's going to reduce the size of those shock waves to a manageable amount and then reduce the speed of it so the compressor can handle it. So good. Just a bonus point there. 13. A pitot type intake is efficient at sonic and supersonic speeds. True or false? Again, you might get true or false questions in the exam, but true or false there?
False.
False, yeah. It's only suitable for speeds up to speed of sound, sonic, or marginally transonic. Yeah.
Subsonic.
Yeah, subsonic only, yeah. An effect can be described as what?
Speed due forward.
Yeah, forward speed of the aircraft. So the intake's moving along with the aircraft. It's the air is going into the intake. So the faster the aircraft's going, the faster the ram effect of the air into the intake. In other words, if there's more air going into the intake, we need more fuel. Yeah.
Yeah.
Increased due to forward speed and also the intake shape as well. Gas turbine engine intake de-icing may be achieved by what method?
Electric.
It can be. You can have electric on there, but generally, what sort do we use? What's the other type? You've got electric and what else?
Ice.
Not de-icing. Electric's de-icing, yeah, we can de-icing by electric, but what else can we use? What we breathe, but very hot. Hot air, yeah? So we can use de-icing on turboprops by electric versions. So we use small accumulation of ice, remove it using electrical heating elements, and we can also use on a gas engine on its own, not a turboprop. We can blow some hot air into the engine to help reduce it. And also the other version, the little rubber tip on the nose cone can help prevent de-icing. But if it's de-icing, then we allow ice to build up. If it's anti-icing, we prevent the ice from building up. Okay. A pitot type intake will incorporate which design feature? In other words, what shape does it make inside the pitot type intake?
Convergent dot, followed divergent dot.
Yeah, mostly a divergent dot. If you get an exam question, I'll probably just say divergent from the tip to the base or the tip to the compressor. There is a small amount of convergence, okay, but generally it is fully divergent. I'll just put this back in 2 seconds. see if we can do this one on here. Is that one there? Right, okay. Yeah, if I very quickly, just to reinforce that, let's draw a very bad intake. So I'll draw that part. So that would be the front of the intake. So you get divergent shape. There's your compressor over here, yeah? So generally it's divergent. There is a very small amount of convergence to start with, okay, just at the very lip of it. But most of all, it is divergence at the back. So the pressure increases and the temperature will increase as well, and velocity decreases. So apart from a very, very small bit at the front, it's generally divergent to the back towards the compressor, okay? Okay, there we go. Oh, good. Good. Yeah, convergent duct followed by divergent duct to increase ram effect, but generally divergent in shape. Some gas turbines have a rubber cap fitted to the nose cone. Its purpose is to, we've mentioned it already. What's the purpose of the rubber cap?
De-icing purpose.
Yeah, low vibration of the rubber tip. It's slightly off center. It prevents the ice from forming up. Good. Yeah, tiny vibration prevents the ice. What shape is formed between the adjacent vanes of a centrifugal impeller?
Happy face.
So is it convergent or divergent?
Divergent.
Divergent, yeah, it's a compressor. It's got to compress air, so it has to be divergent. Okay, to generate pressure from the radial airflow velocity. Compressor bypass ratio can be described as the ratio of
Full steam air and hot steam air.
cool steam air and the hot steam air. Good. Cold steam air to hot steam. The greater the amount of cold steam, the greater the bypass. So the greater the number, 5 to 1, 10 to 1, that means there's more cold air because of the fan at the front of the engine, especially in high bypass engines, to the core hot stream gases. What's the approximate pressure rise for a single stage of an axial flow compressor?
1.2:1.
Yeah, well, 1.1 to 1.2 to 1, yeah. There we go, 1.1 to 1.2 to 1. One set of rotor blades followed by one set of stator blades in an axial flow compressor is also known as what do we call that? Same for a set of NGVs and a turbine rotor is also known as this. What do we think?
Compressor stage.
Yeah, stage. Just a simple stage, yeah. So same for a turbine rotor, set of NGVs is also known as a stage. In this case, look at compressor, so it's compressor stage. Advantages of an axial flow compressor over a centrifugal compressor include several things. What do you think? So advantages of an axial flow to a centrifugal.
High pressure.
Smoother pressure. The centrifugal can give a high pressure initially, but what think about size, weight, and that sort of thing? Compared to a centrifugal one. Again, if you saw the answers down A, B, or C, it'd probably be a lot easier. This is probably the hardest way to do it. So if you can get answers for this one, these questions, you see the answers in A, B, C version of your exam, it should be a bit easier, hopefully. Basically, high overall pressure rise, overall, not initially, but overall. Smaller frontal area, because the centrifugal is quite large and certainly a lot lighter, so it makes it easier to spin. Centrifugal compressors, big, lumpy bit of metal, needs a lot of momentum, a lot of torque to get spinning first, generally larger area. Okay, it has a higher pressurized, but that's it. Just there's no a nice, efficient, smooth pressurized all the way through. Okay, so axial flow is smaller, lighter, and more efficient, and generally a better pressurized overall. What's the purpose of the diffuser fitted to an axial flow compressor? And either or a centrifugal compressor, they both do the same job.
Guide the gas to the combustion chamber.
Yeah, it's also divergent in shape, so it also slows it down, builds up the last pressure, makes it stable for entering the combustion chamber. On an axial flow compressor, it's just a divergent shape, where it is on a centrifugal, it's a radial one, but with divergent shapes all the way around it because of centrifugal action. And basically smooth out and increase the pressure of the air prior to entering the combustion chamber for intake. What are the two main symptoms of a compressor stall?
High temperature in cockpit indication.
Yeah, EGT, we're going very, very fast up the way, yeah. What else?
Fluctuating action.
Fluctuating
Yeah,
RPM.
fluctuating RPM, you'll see the gauge going back and forward, yeah. Vibration, and the good old rumbling noise, yeah. Increased EGT, fluctuating RPM are two of the ones. What's the purpose of the bleed valve operation during engine start-ups? The bleed valve, what's the purpose of that one?
It relieves excess air pressure.
Say again, you're quite there.
It relieves excess air pressure.
Yeah, where from? The front of the compressor or the back of the compressor?
Rear side.
Yeah, the back side, yeah. It prevents the compressor from choking. So the bleed valve bleeds some air from, it takes a tapping from maybe the halfway point of the compressor, because if it takes from the back of the compressor, that's too late. It's going to choke. So remember, on startup, the bleed valve will be open, depending on the speed of the RPM. And as the engine gets faster, that bleed valve will start to close until the engine is now able to cope with the momentum of gas flowing through the engine. Okay, so open to start with at slow speeds, closed at high speeds for a bleed valve. Okay, so it leaves excess air pressure from the rear compressor to reduce the risk of stall. Because if we choke the compressor, well, that means we're slowing it down as airflow is coming in, and that means we could potentially stall the compressor. What's the main difference between wide chord and narrow chord fan blades?
Narrow chord fan blade has the clapper,
Yeah,
and the wide chord is smaller than the narrow chord fan.
yeah, it doesn't need the clapper. What's the clapper also known as?
Shroud.
Yeah, midspan shroud, clapper, also known as
Snubber.
Clapper.
Yeah. Snubber, good.
Yes, snubber.
Fans don't require midspan shrouds, snubbers or clappers due to their reduced length. They're strong enough. What's the purpose of the IGVs, or inlet guide vanes?
Direct the flow to the compressor.
Yeah, at the correct
Angle.
Good, yeah, that's one. Direct airflow at the first stage of the compressor rotor at the correct angle of attack. The ratio of the fuel to air or air to fuel for ideal combustion is
50:1.
15 to 1. In this case, I've put it fuel to air.
I weight, I think.
Yeah, 1 part fuel to 50 parts air by weight. Normally, in the exam, they won't do it that way. They'll write it normally. They'll write it as what's the air to fuel ratio, which is 15 to 1. All I've done is to move them back and forward, okay? I've made it read fuel to air instead of air to fuel. But the ratio is still the same. 1 part fuel to 15 parts air by weight. But it can go up as high as what over the whole engine RPM? What's the other numbers? So 15 to 1 standard, it can also go up to over the whole range of what percentage, or ratio, I should say. remember, it gets a bit weaker. Once the engine gets hot, we don't need such a rich mix. The smaller the number, the richer the mix. The bigger the number, the leaner the mix, the weaker it is. So once the engine is warm, once the engine's at altitude, we don't need such a rich mixture, so it can go down to what sort of numbers? Anybody remember?
What's the number?
45 to 1 and
130:1.
150 to 1. See, yeah, you know it, it's just because I haven't written it down. If you have to see that in exam, you realise, but be careful when you ask this question, make sure they might say the ratio of the air to fuel for ideal combustion is, well, that is 15 to 1. If they write it as, what is the air to fuel ratio over the whole range of RPM, well, that's different. That's a 45 to 1 to 131. So just make sure you read the question, because they might put this answer down and also the 45 to 1 to 130 to 1. Now, they're both right numbers, but only this one is correct for that question. So just take your time with that one. Make sure you read the question. Okay, the approximate percentage of total combustion system air used for cooling is what?
80%.
80%, good. 80% split into primary, secondary, and tertiary. So what does primary do again?
Excuse me, sir?
What does primary cooling air do?
Primary.
Yeah, so what does primary do?
Primary mix with the fuel and support the combustion.
Yeah,
Support
support
the-
combustion, good. Secondary?
Secondary will shape the flame.
Yeah,
Shape
shapes
the
the flame.
flame and
Tertiary?
continuous.
Tertiary will cut off the flame.
Yeah, cuts off the
Cut off
flame.
the
Good.
flame.
So primary, secondary, and tertiary. Now remember, dilution air is also known as tertiary air, in case they put a question like that in as well. So dilution air is also known as tertiary. It does the same thing. It cuts off the flame, just in case they change the wording. Okay. What components are typically found in a combustion system or a combustion chamber?
Igniter plug.
Yeah, igniter plug. Yeah, give a spark. What else have we got?
Combustion chamber itself.
Yeah, the combustion chamber. Yeah, we'll have the liners, the inner liner, outer liner. So you've got spark plug, igniter, the combustion chamber. What else?
Burner.
Yeah, the
Burn.
burner. Yeah, whatever type of burner it is. Yeah. So igniter plug, the fuel burner, and yeah, the combustion chamber or the flame tube. So the flame tube is the part that holds the flame in. Then outside, the casing outside is the outer layer. So you have a two-layer thing with the combustion cooling air going in between those layers. I've mentioned already, what's the purpose of dilution air in a combustion chamber? I've told the answer in the previous question. It also is called tertiary air, so it must do what?
Cut off the flame.
Yeah, cut off the flame. Cut the flame off, which helps reduce the temperature, so we don't have a hot flame touching the nozzle guide vanes. Name a type of combustion chamber. We've got 4 of them.
Multiple
Multiple chamber, yeah.
turbo annular or cannular,
Yeah, tubular and cannular, yeah.
annular and reverse flow.
Angular and reverse flow, good. Okay, very good. Combustion process creates what?
Combustion process.
Carbon.
Yeah, creates smoke. What else? What about the nasty stuff?
Hydrocarbon.
Yeah, hydrocarbons, all good stuff. Yeah, carbon deposits. Again, it can reduce by using bleed air over the burners, etc. We get carbon monoxide and all that good stuff. So that's just one of the examples there. If you burn anything, produce a flame, you can produce carbon. Carbon can stick to certain components, but we can help reduce that by inducing a flow of air over the burners to help reduce the carbon buildup. A simplex burner is known as which type of burner?
Atomizer.
Atomizer, yeah. We need to atomize the fuel, put it in a spray into the combustion system, then ignite it, just like a shower head. So atomizer. The shape of impulse reaction turbine is described as
Happy face.
with a
Yeah, happy face.
not a happy face.
Opposite.
No,
Opposite.
no, no. Reaction turbine.
Opposite.
Opposite, like
Yeah, cup shape
banana, banana.
with an aerofoil.
Shape,
Yeah, so it's a tick. Yeah.
And Nike shape.
oh,
Nike
impulse
tick.
reaction. Yeah, impulse reaction is Nike, big Nike tick.
Big Nike tick. Yeah. So yeah, my bad drawing again. Make sure we're happy. Fine. So you'll have that sort of shape, yeah? Impulse reaction. And whereas a impulse one will just simply be happy face, okay? So impulse reaction, so basically a wing, Nike tick or Usain Bolt, or happy face is for impulse, okay? Impulse happy smiley face or cup shape. Impulse reaction is a cup shape with a tick. Okay.
Aerofoil shape.
All right.
Impulse
reaction.
shape.
Impulse. Impulse for direct impingement, like an APU turbine, a starter turbine, that sort of thing. But for a normal turbine and a jet engine, you want to extract as much gas, energy, or energy from the gas, you'd say, from the airflow. So as the air's coming in at the angle, it hits the airflow, and goes along the airfoil stream. So we're getting as much energy from the air. Air coming to an impulse one just hits it roughly in the middle, sort of thing. Okay, so it just hits it going fast. We're not bothered about efficiency, we just want to hit it. Okay, there we go. So impulse reaction is this one, and the impulse on its own is just a cup shape. Okay. Initially a cup shape, followed by an aerofoil, basically with a wing attached to it. Nike tick, Usain Bolt. What is the purpose of the nozzle guide vanes? What's the purpose of nozzle guide vanes?
To guide the gas flow.
On the turbine. Yeah.
Yeah, it does the same job as an IGV, but it's in the hot zone. Okay, IGV directs it onto the first stage rotor. Okay, and that'll compress it, whereas an NGV guides it onto the first stage rotor at the correct angle, but also through a convergent duct, so it helps speed it up as well. So accelerate the gas flow and direct it onto the rotors at the correct angle. What does the abbreviation ITT refer to?
Interstage turbine.
Temperature.
Turbine, yeah.
Interstage
Turbine
turbine.
temperature. Right. Sometimes it might be called intermediate. Interstage or intermediate, one of the two. Turbine blade tertiary creep is what?
Last stage.
Stretching the blade, isn't it? So the last part, we've got primary again, secondary and tertiary, not to be confused with the airflow. It's the primary, it's initial stretching of the blade. Then the secondary, it will continue to stretch at a slower pace, but then tertiary, that's the point when it's guaranteed it's probably going to break off at that point.
It's twin.
Yeah, tertiary, the final stage. The final accelerated growth or stretch of the turbine blade prior to fracture, breaking off. 39. Turbine blades with a fir tree fixing design will do what? Or what's the purpose of the fir tree design?
The load.
Yeah. Into place the centrifugal force at higher RPM. So the V shape it forms, those little serrations at the V shapes, they spread the load. So at centrifugal force, it spreads the loads out. So that little tiny blade, it might be 2-ounce blade, there'll be about 2 tons of force when at high speed, so it can hold that blade in position. Turbine blade cooling air is taken from the rear stages of the compressor because, or to prevent what? So we take cooling air from the compressor to cool the turbines, but by taking it from the
To
compressor,
save the turbine blade from the creeping.
not creeping, but it prevents it from what else? We've got the air from compressor. Thermal shock, yeah, that's what we're looking for. Thermal shock, yeah. So the high temperature from the compressor, it's already warm. So when we put it to, okay, it's a very hot turbine, but because the compressor air is already about 500, 600 degrees, that's still quite hot, but it's a lot cooler than the turbine blade. So we can cool the turbine, but not have an instant reaction from cold and hot type hot type temperatures. Exhaust noise can be reduced by the use of or doing what?
Exhaust noise.
So exhaust noise. How can we reduce exhaust noise?
Reduce the throttle.
Yeah, reduce throttle. It's one method, yeah. What else have we got? So we can reduce throttle. Lots of different methods we can do to help reduce exhaust noise.
Shape of the cone set.
Not the cone. Exhaust maybe. We can induce air. Yeah, we can induce air into the exhaust from outside because with the low pressure air coming out very fast of the engine, which means the high pressure air outside the air will come into it and cover up the hot air. So we can use like insulating blankets as well, ejectors, reduced throttle settings, and different insulating materials as well. And the last one, what's the purpose of exhaust cone?
To form a
So purpose of the exhaust cone?
To increase the velocity of the exhaust.
Increase the velocity, no.
Yes.
decrease the velocity.
Remember, it forms a divergent shape.
Diverse.
Yeah. Let's see, where's my pen gone?
To increase pressure and temperature.
Not increase pressure and temperature. Well, it will a little
It's a
bit.
shock.
It stabilizes, yeah. So we've got pen. Right. So there's the turbine. There's the exhaust cone. And let's give it a different color. There's the exhaust. There'll be a propelling bit there. Exhaust and a bit convergent then. So this part here, okay, is divergent in shape. So it will slow the air down initially. The support struts that hold the cone on will help guide the air and straighten the air out. So we slow it down, and because as the air is coming out of the turbine, it's swirling, isn't it? It's swirling as it comes out. So it straightens out, the cone slows it down initially, helps prevent wastage of loss. And then eventually, once it's stable, it will go out to the exhaust nozzle, which is convergent, which will propel it back out. So it just helps stabilize the exhaust gases. Okay.
It creates sonic, right? On the day.
It will be sonic here, yeah. Eventually. Once it gets to speed. All right, so diffuse the gas flow. So just think of the cone makes a divergent shape. So diffuse the gas flow from the turbine outlet. The cone also protects the back of the turbine disc because the middle of the disc is going slower than the turbine blade going round, isn't it? Because it's closer to the axis. So the hot air can concentrate in there. So by having a cone in there, that also helps protect the back of the turbine disc. Prior to normal thrust reverser operation, what conditions must be met? So before we select thrust reverse, How can we select thrust reverse? What conditions should we be at first?
Minimum RPM.
Minimum RPM, idle, yeah. And also
Weight on wheel.
weight on wheel switch, on the ground in effect, yeah. Minimum RPM settings and weight on wheels, yeah. Name a type of thrust reverser system.
Cascade.
Cascade, yeah, the one slides back and forwards.
Retractable.
Retractable ejector. And the one looks like Pac-Man.
Clamshell.
Clamshell.
Clamshell door, coal seam, cascade reverser, and buckets or retractable ejectors we call them. What is the angle of the cascade vanes? Just as an extra one there.
Is 45 degree.
Yeah, they're all 45 degrees. So there we go. Properties of cascade vanes, any thrust reverse system to direct the gas flow forward at the correct angle, in this case 45, hence the question number is also 45.
45. Yeah.
There we go, end of revision again for that one. So just to recap the ones we've done there, that's a good point to stop for now. So let's go for a